Okay, this is a short video of a interesting problem that I had with a audio cable patch cord. So I had this patch cord, which was a male plug to a male plug cord for a long time, and I went to use it, and I noticed that it was shorted. There was a short between the tip and the shield on this TS plug. And I thought that probably there was a short inside the molded plastic. Now, a lot of times you can get an open if you pull on the cord and you stretch and break one of the conductors on something like this. But this one was giving me a short, so I cut the cable into two pieces with the idea that one half might still be good and the other half is where the problem is, and then I might be able to just use one half for some future project. But what I found was that when I did it, I was getting a short on both of the connectors. So just to show you an example of that, here's one of the connectors that I have isolated. And when I measure the resistance between the tip and the shield, I'm getting 9.7 ohms. Okay, now it's reading 9.7. Okay, fine. Well, that was, I thought, a little bit unusual. I wasn't sure where that was coming from, and the number was very close to 10. Then I checked the other one, and the other one was also showing 10. And in order to try to isolate what was happening inside of these connectors, which I thought it was unusual that they would both show a failure and it would both show 10 ohms. So this one I cut in half again. And if I measure the resistance between the tip and the center conductor, I get 9.8. It's incredibly close to that other number. And let me show you a close-up of the cross section, if I can get this in the field of view here. When I cut this, it looks like it's not really focusing very well on it. Okay, but anyway, there's a center conductor, and then there are, you can see the two wires, the two copper wires that are in the molded plastic. They don't have any insulation around them at this point. There we go, got it in focus. They don't have any insulation, okay? They've been fastened, soldered to the tip somewhere in here, okay? And now the copper wire is just running until it gets to the end of the connector, okay? And based on just ohming out these connectors, it seems as though, so here's a picture of the connector in cross section, not in cross section, just in the side view, and then here I have I cut it in half, a cross section, in this direction, lengthwise, to show you what appears to be inside of this. Now, when you have one of these that's failed, sometimes you can get a razor blade or a knife and cut back this plastic and then resolder the connections, and then put some heat shield over it and possibly some epoxy to glue it up. Then you can just use it again, but you can also buy replacement plugs. But the funny thing about this one that was this 10 ohms that was showing up on both of them, and it appears as though the center conductor, the tip runs through the center and then is connected to this metal post, which has an impedance of about 10 ohms. Now, the wire is soldered to it on the tip end, and the resistance is on the post is after where the wire is connected. And then on the shield, it's soldered to the shield portion of the plug, and then the copper wire runs through the molded plastic. Now what seems to be happening on both of ends of this is that the shield copper is touching the end of the post, and that's creating a 10 ohm short between the tip and the shield. On this this one here, in addition to the 10 ohm short between the tip and the shield, I'm also getting 5K of resistance between the tip and the center conductor, and that shows that that wire has been stretched. You can see it there, 5, now it's reading 4.7K. Okay, that wire is failing. It's been stretched, and it's nearly going to open up. Now, why these would both have 10K in them, I really have no idea. And why they would both fail. The reason why these fail usually is because someone's pulling on the cable, and they're not gripping it by the molded plastic. But the other thing is, sometimes the cable just has weight applied to it. Like you might trip on one of these cables, and that pushes this thing sideways, or pulls out on it, and they don't last forever. And these ones, of course, are more difficult to repair because it's molded plastic. So I just thought this was quite unusual that they would both fail, because normally what happens is one side of the cable fails, then you stop using the cable. For them both to fail might have happened on one catastrophic event where there was so much force on the cable that it actually damaged both ends. And the thing about this that I really couldn't find any reference to is why there would be 10 ohms in this metal post. I was expecting this post to give only fractions of an ohm. And so anyway, I just thought I would share that with you. Maybe somebody else has seen that before. This is not a repair at all. These devices are broken. This one is pretty much trashed. The tips of these are probably still perfectly good and could probably still be used with soldering to them, but I have no plan to do that at this point. Thanks.